Section 10.4, the nature of sound. So we talked about how sound is a longitudinal wave. When you speak, it vibrates the air in front of your mouth, and that vibration travels through the air to the person who hears you. It travels to their ears. Sound waves are just vibrating regions of compressed air. When we speak, we compress the air, and so the compressions travel through the air. And because those compressions travel through the air, the space in between is spread out. And these spread out spaces are called rarefactions. This is where the air spreads out in between. It's a representation of what the sound wave would look like in the particles of air. It's going to compress some and spread the others out. In terms of sound travels at about 340 meters per second at room temperature. At colder temperatures, it travels a little bit slower. At warmer temperatures, it travels a little bit faster. But in general, sound travels at a measurable velocity or measurable speed. That means that if you're sufficiently far away, you can measure distances using how long it takes for sound to reach your ears. For example, as a child, you might have been told that when you see lightning strike, if you count until you hear the thunder, then however many seconds you count, that's how many miles away the lightning strike was. Though the 1 second to 1 mile is a little off, it's not a bad approximation. When lightning occurs, lightning is very bright light. Light travels at 100,000 times the speed of sound. And so when you see the lightning, you see it almost instantaneously as it happens. But the thunder, being a sound caused by the rapid compression of air near the lightning, that sound takes some time to travel. And so if you count, you can determine approximately the distance to the lightning strike. It's very common now that sound waves that are generated are done using speakers. The most common things you're going to hear in your life are people's voices and speakers. Speakers use an electrical signal to essentially induce a vibration in a paper cone. So the electrical signal is run to a magnet. As the signal changes, the magnet moves the cone inside of the speaker. That cone vibrates the air, and that sound travels through the air. If we wanted to look at the electrical signals that would cause the vibrations in a speaker, we can use a device called an oscilloscope. An oscilloscope is just used to look at electrical signals. You generally use it to measure oscillations of electrical signals, so like AC current oscillating back and forth. But there are many, many other uses it can be used for. So the speed of sound changes based on the temperature. At 20 degrees, it's about 340 meters per second. For every 1 degree increase above that, the speed increases by about 0.6 meters per second. However, in water, sound travels much faster than in air. And again, it's because the liquid molecules are much closer to each other. In steel, the sound travels even faster. And again, because it's solid and those solid molecules are locked into one another. Finally, we just need to discuss the different ranges of sounds. We generally divide sound waves into 3 different categories. The first is what's called infrasonic waves. These are waves that are less than 20 hertz. So generally, if a speaker or something is producing this type of sound, you won't be able to actually hear it with your ears, but if you got close to it, you could feel the speaker moving, or you could feel it in front of you. It would be moving the air still, it's just not at a high enough frequency for your ears to pick it up or your brain to register it. Above 20 hertz, but less than 20,000 hertz is what's known as the audible range. Every person has a different audible range. The upper range, those higher frequencies, can only be heard by those that are very, very young. As you get older, those higher frequencies go down to, at about middle age, the upper limit is somewhere around 15,000 hertz. In older age, it's somewhere around 12,000 hertz. But we generally refer to these as the audible range because people can't hear them. Anything above 20,000 hertz we call ultrasonic waves. Ultrasonic waves are just sound waves that have a frequency of greater than 20,000 hertz. You won't be able to hear these. But animals can use ultrasonic waves for things like echolocation. So dolphins and bats use similar types of waves. Humans use ultrasonic waves in ultrasounds in order to see inside of a woman's uterus.